There we go. Okay, we're good. All right, keep going.
Okay, so I mean, where we left off essentially was okay.
Mm-hmm.
We know when it's invalid parentheses when the left and right brackets don't match up.
Mm-hmm.
So it's left equal 1, right equals 2.
Mm-hmm.
So you can see that it's not a valid pairing. So maybe we can only remove when this condition matches up. So only remove when number left not equal number right.
Okay.
So yeah, but while we're iterating, it might happen. The case might be when we have an opening bracket, like left. I mean, yeah, just like opening bracket left equal 1. So that's that. So, but at that point, right will be equal to 0 since we're iterating over the current string. Um, so if we so we have to handle that case. So what happens if we remove the current one then? If we remove the current one, then we need to define exactly what to remove when when we say only remove when when the number of amount of left brackets equals the number of right brackets.
Okay.
Number that. So number left 1. So how should we remove it if we just encounter this case? So if we're going through the string 1, and then we go through the right, so we're iterating. That's 1. So what happens if we encounter yeah, that's a totally invalid string base
Okay.
case. Left, right. I guess we can go for the opposite way. So we can count the number of parentheses. Let's try the opposite way first. So we know that left equals 1, and right equals 2.
Okay.
So now we know we have the total amount of parentheses in our thing. So now we know how much to remove. So basically we can iterate through the string again. So if we encounter a left bracket, oh, it looks like left is less than right. So left less than right. So don't remove it.
Okay.
And then we see that. Now we see it's a right. We see that right is equal to 2 and 1 is equal to left is equal to 1. So we see it's a right bracket. Now we see that left left is equal to 1 and right is equal to 2. So let's try removing this current bracket. So if we remove that one, our string will essentially be still this. That will be our result string. So then we know, and then we check if that string is valid. We see that string is valid due to some check.
Okay.
And we see that the amount of brackets that we need to remove is equal to 1 in this case. Yeah, the amount of brackets we need to remove is 1. Left, 2, right equal 2. Yeah, and then that just becomes finding all possibilities for one bracket. I think there's a better way to explain it and do it.
Honestly, I've been zoned out for the past 10 minutes because you are not making much sense, but it sounds vaguely right. So I'm going to say just, if you have your idea solid, just code it up.
Okay. It's not too solidified just yet in terms of left less than right. This idea isn't too well defined yet.
Okay.
We know left and right is that's when we should remove. Amount of checks. Yeah, left and right. I mean, I see a relationship between the difference, so right minus left, but I know that doesn't seem like it'll occur in all cases, because what happens if we have then that doesn't really go out too well, or if we get the absolute difference. That might not work out too well either. So let's scrap that idea. I want to like make it sure that I know I'm right. For the idea first. Because we have a brute force one over here, sort of, but the idea might be a little bit swapped. The way we operate on things might be a little bit swapped. So we know we have left less than right is equivalent. We only remove when that happens. Left is equivalent to right. What happens if we have but what happens if we have more rights, more lefts than rights? So that wouldn't be too well. Because then in that case, left would be equal to 2, right would be 1.
Let me know when you want to throw in the towel.
Okay. I guess you can just throw in the towel now, I guess.
Okay. So what do you think you're doing wrong?
Other than a lack of idea of how to proceed. I think initially I for the initial brute force solution above here, like on page 2. Well, not page 2, page 2 and 3.
Yeah, I got it. Yeah.
The initial one that might have been too focused on one test case, but that was sort of a jumping board for me on how we can generalize it. And then the next progression to that is removing k parentheses for each number. Like, we get try removing every possible parentheses. I am missing like that insight, and then after that I tried reasoning about an optimization. I didn't really see how that worked out, and I should have probably abandoned that a little bit earlier. Yeah.
So let me say this one, because first of all, yes, you're right. You wasted 15 minutes on the problem trying some overly complicated solution again. And to me, it's like, yeah, okay, it was testing it with one idea. That's right? Now all I have to do is just do it for k possible parentheses. So in other words, just instead of trying to remove one parenthesis, try to remove all combinations of k parentheses. How would we do that? Well, we just do a countdown recursively, right? And once we removed the, like for each, like you said, for each one, just decide whether or not you want to take it, right? You either remove it or you don't. And if you remove it, you count down k, and you recurse until k equals 0. And then you record
Yeah.
the string, and then you compare all the strings that are valid. That would get you to an answer. That's fine.
Yeah.
The problem is that you obviously that was going to be very inefficient. Now, my question is that, well, this was right, and then you just abandoned it because you overly focused on one test case. So, in other words, all you have to do is just scale it out generally. Instead of either remove the character and then check the rest the string is valid, just try removing combinations of characters. It's just a combination, and you can return it to a combination permutation problem. If I said, give me all the possible, combinations of strings that occurs by removing k number of parentheses, you could come up with that.
A subset that removes all k parentheses.
That removes. If I asked you literally just that, yeah, it's like give me all the strings that can after k number from 0 to k number of removals.
Yeah, I think so. Yeah.
Yeah, you probably
It'll essentially be the above algorithm.
This is just a recursive problem. It's a subset problem.
Yeah.
And then all that it is from the subsets, just count the number of valid parentheses.
No.
That should have been like your first instinct. The very when I say very naive and simple, I'm literally talking about the most naive and simple, stupid answer that anyone can come up with without even training in data structures or algorithms. I don't think anyone needs a structure and train data structures and algorithms other than like maybe recursion. That's it. To do this one.
Yeah, I mean, I think I was thinking about permutations and combinations. I guess I didn't think of the removing in combination with those.
It is a permutation combination problem. It's just generating subsets. Every single possible subset.
Yeah, combination. Yeah. Every possible subset. Yeah, every possible subset.
And then just like out of all the possible subsets that are from 0 to k removals, just count the number of ones that are valid, which you, like you said, you just know if the parentheses match it up. Right?
Yeah.
So that's really it. And then after that, it's really just it's just modifying that recursive problem over and over again. So let me do that for you, and let me show you exactly how to do the problem, and this will make sense, right? So then, say for I between 0 to k, we're gonna recurse into removal, passing in k.
Where are you typing it? Problem sheet.
Problem sheet, yeah, right. Okay, so then our what's it called? Recurse into removal k. So then removal k, right? So let's call it our removal function. Then the base case. Fucking internet. Google. Hey, hello.
Hello. Yeah.
Yeah. Okay. So Google's actually going down. Holy shit. I can't actually type right now. Damn.
Yeah.
Yeah. Google problem. Okay.
And Google's still up for me. I think that might be an offline thing than your internet.
What
maybe?
the hell? I mean, I'm not sure why. What the hell did I do? Yeah, it's literally telling me Google can't be reached. Are you kidding me? Alright, let me try this. Yeah, my internet apparently hates Google right now. What the fuck?
Maybe your IP or something changed suddenly.
I doubt it. I think the stream went down because of my internet as well. Holy shit. DNS resolution problem? Maybe.
Maybe.
God damn it. Alright, Google's down. Alright, let me do this then instead. Hold up, let me just since this is more important, let me go ahead and just record the rest of this, and then let me open up a Sublime pad, and that'll work.
Okay.
Give me a sec. And then I'll just do this. Okay. Can you see this?
Yeah.
Great. Okay, so remove a number of invalid parentheses in order to make the substring valid. Return all possible results, right? So what I would do is start with a very simple one, right? Remove some k number, right? Remove k. And then I would say my base case, right? And then recursive case. What's my recursive? My base case is if k equals 0, which means number of elements I need to remove, add the candidate string to global list, right? And then recursive would be remove. See, remove It's called remove from I just say remove I from string, and then recurse with k minus 1, or don't remove I from string recurse with k, right? Something like that. Of course, I'm paraphrasing here, and of course, there's like some details. Or say I is that index I'm at, right?
Yeah.
Of the string I'm at. Of course, there's like ways of doing, like, what's my running candidate, which would probably be like a list of, let's say very simply just like a list of integers, which is like indexes to omit or something. This is like very obviously this is not going to be it, because it's going to be very, very long or whatever, but you get the idea, right?
Yeah.
And so, but the pseudocode is going to be like that. So now, all right, so what's the next thing I need to do, right? And then outside of the remove, we'll do this main here, and then check the check the all the candidates via validity, like you said, which is check if number of open braces equal number of closed braces, right? So next thing, what is my inefficiency here? Well, part of it is like let's start with the easy one, the validity checking, right? I need to check if the number of open and closed braces are going to be the same, right? So in other words, I only need to recurse and then add the open braces or closed braces. So let's start with there, right?
Yeah.
If I can somehow pass that information along, I don't have to do this information at the end, because I'll be basically. Does that make sense?
I think checking for the validity is a little bit more difficult than checking if the number of open braces equals the number of closing braces. Braces, right?
If the string if the character at the index I'm looking at is open or closed braces, I can just increment or decrement the number, or I can increment number of open braces or number of closed braces based on that, right?
Yeah, but what happens if they can still be equal? Like, what happens if we have closing? That's not valid, but the numbers are equal.
What happens if what?
If we have closing brace and then opening brace, the numbers of the opening and closing braces are valid, but it's not actually a valid string.
Oh, that's true. And also there's also the what's called the issue of k to go around, right? That's two. We can knock two things out with one stone, right? We can just, if we somehow eliminate k as an explicit reference, which k is obviously 0 to limit of string, we can actually solve this problem a little bit better. So what if I could remove k, or I do the validity check, right?
Yeah.
So in other words, what I'm gonna do is I'm gonna modify my base case. What I'm gonna do is I'm gonna say, hey, yeah, well, the moment I'm at the end, the moment I've iterated through the entire string, I'm gonna keep track of instead of index commit, I'm gonna say, let me go to let me go here, right? Let's say attempt number 3 or whatever. So in other words, I'm not gonna do k, I'm just gonna do I. So if I is equal to string length, then I'm gonna check my open closes, right? So then check, and so I can actually take out the indexes to omit, right? So I'm going to check my open and then close. And if open and close, then what I'm going to do is I'm going to also be able to add that string, to my master list, my global list. Because now I've solved the what's it called, the validity check, right? Right, I'm focused on one thing and one thing only. I know that there's some issue with this, but we'll get to that later. But now I'm going to recurse, right? So now I'm going to have either remove I from string or don't remove I from string. But that means that I just need to check if the there's two cases also as well. We'll handle the letter case later on, right? So in other words, I'm going to check if if the the current element is open, or if the current element is closed. Right? There's only two possibilities. I can also do it from within here. In fact, let me do that just to prove a point. So let's say I remove a element from the string if it is a what's it called? I should say open brace actually. Should I do it from count up or count down? I can do either way. Let's do a count up. It doesn't actually it I don't think it actually matters that much. So in other words, let's say if I'm doing count up, then it's probably easier to count it as open close braces. So let's flip it around, but it doesn't really matter that much at the end here. So let's just say if my current I is equal to the open parentheses, right? And
Yeah.
I is equal to close parentheses. I'm just going to divide it up another way, just for the sake of simplicity, but it really doesn't matter. So then I'm still going to try remove I, and then don't remove I, right? And then same thing here, either remove I, and then don't remove I. So that's basically what's going to happen here. So when I go to remove I, I'm going to increment my index, right? But then I'm also going to increment open plus 1. And then index I plus 1, right? And then here, don't remove, just we do I plus 1 here. And then for close, I do close plus 1, I plus 1, and then don't remove I, so it's going to be I plus 1. This would get me to an answer, right? Of course, there's like a few complicated, we can be a little bit more, we can be a lot more, efficient about this, right? So the first things first is that I need to check if the number of elements I've removed. I need to keep track of that counter, right? Because that way I can choose whether or not to add that string to my global list. If I kept track of the number of elements I've removed so far, I can actually choose whether or not to record this answer. I mean, in theory, I could also do it by the number of open and close. Actually, I could probably do it by doing just like, a string dot length minus number of open minus number of close in order to get me number of elements to that I've removed. And then I can just record that, right? And then a global, because this would be effectively what that is, right? And then I'll return out of this. So that would work. And the next one would be, all right, well, you mentioned it actually before, right? Where it's like, oh, what happens if I have too many open and too many closes, right? Well, that will only impact whether or not I want to take out a close parenthesis, right? So then now that would be, okay, well, in order for me to take out a close parenthesis, then I need to say either open is greater than close. So I'm counting up, right?
Yeah.
So that's the part so I'm gonna add your optimization, your actual optimization here, and then just like add in a close parenthesis or some shit. Okay, and the last one will be, all right, well, what happens if it is neither? So if open or close, because we have those extra things in there, right?
Yeah.
Just means hey, let's add it, and just index plus 1, and then add it to candidate string or whatever.
Okay. Yeah.
Yeah. In other words, you see like how I basically just took one observation, one idea, and then just like I went for the high level, and then just said, okay, let's take this out, because it makes sense. This one is still inefficient, and this makes sense, etc., etc. It's literally just evolving the answer, except I'm just optimizing smaller and smaller portions at every single time. Does that make sense?
I'm still a little bit confused on the global stuff though.
So this is my global candidate, right?
Yeah.
Out of all the possible attempts I'm trying, all I'm doing is just saying, hey, yeah, let me record the number, because this really represents minus the number of removals or something, yeah?
Yeah, like the number of removals.
So do you understand this one?
Yeah. It's just, how does that help us towards the solution is what I'm saying.
Because I only have to iterate through the elements one time. I don't have to come up with a list and then recheck all of them and recheck each one of the end characters, right?
So we use global to prune some of the elements we need to iterate through?
I don't have a list. That's a simple answer. I don't have a list of candidates that I need to iterate over.
Yeah.
I just have one thing that is literally just a number. It's a math operation now. It's not. I don't have to iterate over the candidate strings. It's just a number.
Yeah, like that just keeps track of the number of elements you remove, but that's essentially zero, isn't it? That's always like, no, you have to check your open versus closing. Isn't that 0? Because technically you can remove 0 parentheses at all, and that'll always be 0.
Well, then I have 0 number of removals, right?
Yeah, but I mean, Yeah, zero number of removals, but it can still be an invalid parentheses string.
Yeah, that's fine.
'Cause-
But that means that it would fail this open close
Yeah.
check, right?
I mean, I equals string. Oh yeah, okay, yeah. If it's at the end of the string, okay,
Yeah.
that makes a little bit more sense. Yeah,
So, but you saw how I evolved the problem, right?
yeah.
I took literally all your observations, just did it step by step. There was no insight. There was no extra insight I had to do. I mean, maybe the open close. All I did was like streamline it. That's it. I didn't do anything extra. Nothing fancy. Nothing major. That's the difference.
Yeah. So you went from you remove K like remove the parentheses at this index or don't remove it, and then you increment K, and then after that we optimize it to include only remove when more opening parentheses than closing parentheses.
Yeah. I mean, I just literally evolved your solution, and just said, hey, you know what? It might be easier if I did this instead. But the proof I cases doesn't really matter because I remember how I said before. Oh yeah, let me do remove and don't remove, right? It does.
Yeah.
I could literally just do the exact same shit. It's like if remove open, then have a case for open parenthesis, close parenthesis. I just did this because it was a lot easier.
Yeah. Remove or don't remove, yeah.
It's not important that you understand what's it called. You memorize the solution. That's not important. What's important is that you understand how my idea evolved. That's what you want to copy, right? The entire time we've been focusing on improve your ability to grow your solution and make your approach bulletproof.
Yeah. I think I'm still a little bit struggling on thinking of a clear brute force speech for some of these.
Right. That's why I keep saying explain things like year 5. Come up with a brain-dead brute force solution that anyone can understand and that will work under every single possible circumstance. That you know.
Yeah.
And every single time, all I've done here today was just exactly that. All I've done was just come up with a very, very dumb solution and point out, hey, I can optimize this. I can optimize this. And the first problem I gave you, which was the find the strings within the set or whatever.
Yeah.
Was literally the way you're gonna get the optimal solution to that one is literally just doing that exact exercise. What's inefficient? It's everything we've talked about from day one.
Yeah. Yeah.
And what really got me mad was the fact that you basically abandoned everything we did from day one.
Yeah.
Where's this like, oh, I'm gonna try this random bullshit coming from? I need to know. Like, you weren't doing this before, and I don't think you were doing this a few days ago.
I don't know. I guess there's a little bit of panic, I guess. That, okay, this is the first brute force solution I can come up with. Let's get it over with really quickly, see if it's good or not. If it's not good, then let's move on to a new solution.
So you're literally telling me that was the easiest solution that you would come up with that worked?
I mean, I'm more like not the easiest, more came into.
Sorry, what was that?
Maybe not the easiest, but like it was the first one that came to mind.
Okay, so the first one that came to mind is not the easiest, but it was the first one.
Yeah.
What's a good analogy for this? Let me think. That's hard to come up with an analogy for this one. It's just your first instinct's to overcomplicate. If your first instinct's wrong and you have a tendency to overcomplicate, you probably would try to just go with the easy solution, right? Oh, I know. Let's say there is, how do I describe it? You're walking to a university building and there is there's a rock in the middle of the road, right?
Yeah.
Your first instinct would be to move the rock. Except what happens if the rock's like 1,000 pounds?
Yeah.
What's the easy solution to this problem?
Depending on how big the rock is, I can move around it.
Yeah, even better. Find another fucking entrance.
Yeah.
That's a good analogy, actually. Literally, your first instinct, move the rock. Second, the easiest problem, just find another fucking door. That's literally what we're talking about here. Find the path of least resistance that is simple, easy, and that works. And you can always optimize over it later. Take the free fucking lunches, in this case. So, that's all I got for today. And don't apologize to me, dude. Apologize to your future self, because if you guys still have a weekend to turn this around. The question is, how badly do you want to turn it around?
Yeah.
It's like,
yeah, I do want it back. Yeah.
If you want it badly, then you're still making mistakes. This is the exact same like thing from day one. I don't know where it's coming from, but I can only point it out to you. I can tell you, hey, make sure you be super, super critical of yourself. Make sure you understand every single little detail of what you're doing wrong. Try to find out if you can do it better without sacrificing stability. You know, and so it's literally just how detailed you want to be. And there's many, many times in your practice diary you said, oh, I'll do it later, and later never comes. You know, and you're not at, like, if you look at your diary history, it doesn't lie, actually. In fact, I bet you if I go up to like row 120, yeah. So, okay, so, yeah. Delta, yeah, your delta has like always been like 1 lines or some shit like that. It's like you've never, it's like up until like, I would say probably around row 140, I would say, it started getting better. Yeah, 130, 158, 160. Yeah, I mean, I'll be generous. 166, right? I'll be generous here. 616. So it was like basically last week.
Okay.
So I mean, the past is the past, right? You did what you could. All you can do left is really make sure that you really review your mistakes that you've made in the past and try not to make them again. Like, do you even scroll up? Let me ask. Do you scroll up through your practice diary and look at all the past mistakes that you made?
For the earliest ones, after I did them the second time, not really. But for the majority of them ones, I haven't really again.
Yeah, so the answer is no.
Yeah. Okay.
There you go. It's like, why are you making the same mistakes again? Have you tried to make sure every single time you do a problem that you don't make the same mistake again? So your practice is showing through. Eventually, your practice, like your practice converges with performance. Eventually.
Yeah, I mean, currently what I'm trying to do is, well, my focus was trying to create bulletproof my idea, but if my idea was really crappy in the first place, I guess there's no point of bulletproofing that.
Yeah, that's it. So all you need to do is, like, even if you like, is bulletproofing your idea and coming up with a simple idea and iterating over it mutually exclusive?
No, not really.
There you go.
Yeah, I guess like, because a lot of the times in my practice diary, I've been cut off. I've been like wasting time because I got one test case, or I didn't consider like a specific edge case, or I got a typo or something. So I wanted to like really make sure that I got everything in order. Like got all the test cases passing. But I guess in those ideas, my idea was right. It was simple enough to make sure it was right. But now in the most recent 2 questions that I did, they're pretty bad in the beginning with, but I just kept going on with trying to test it.
I mean, these aren't even that difficult questions. I can tell you, we give more difficult questions than Uber. This is literally just a recursion problem, and then just iterate over and over again to try and, like, you know, make it a little bit more efficient.
Yeah.
It is not terribly difficult when you break it down.
Weak spot of mine is still recursion, even though, yeah. Well, thinking.
The first problem wasn't even recursion. This problem.
Yeah, the first one was just me being a bit very stupid.
All right. So I mean, I'm not gonna harp on it anymore. Just, you know, think about like what you want and how badly you want it, and we'll see what happens. But for tonight, take the rest of the night off. Start fresh tomorrow morning, and really, I would suggest just keep doing some LeetCode style problems like this. I think this one's even a LeetCode problem. And try the homework, by the way. The first problem I gave you, do that one for homework, and just write it up. You know, like write up how like what steps you're doing, why it works, why it doesn't work, or what's the inefficiency about it, and then what's it called, iterate over it.
Okay, so like essentially go for brute force and then iterating.
Yeah, do exactly what we've been doing since day one, and you'll see how
Okay.
easy that problem becomes.
Okay. Do you have like a for it? I guess so I can compare
what?
it to a solution.
No, I'm not gonna give you this. I'll give you the solution when we meet on Sunday, and it better be fucking right. This literally means you have to be super fucking careful. Like, really make sure that it's bulletproof. Make sure your idea is right. Make sure you test under all cases. Because there's no point in me giving you the answer. You're just gonna say, "Oh yeah, I made this mistake. I'm not gonna make it again."
Yeah.
So I'm not gonna give you the answer until until Sunday. So.
Okay, so I'll work on that. The first thing I'll do is working on that the block of text problem first.
Yeah.
And then try and go do some more LeetCode questions.
Yeah, and really scrutinize every single mistake. Don't just wave it off. Don't just say, "Oh, I'll solve it later."
Okay.
All right. Anything else?
I think that should be it.
All right.
I'll go work. A lot of work to do. Yeah.
A lot of work. Try to make it. Well, we'll see if we can. 4 days.
Yeah.
Make it count.
Yes, sir.
All right. Talk to you later.
All right. Talk to you later. Cheers.
All right. That's it. Sorry about the stream, guys. It kind of got cut off a little bit due to internet, but hopefully parts 1 and 2 will stay up. I'm gonna sign off now. I need a shotgun this White Claw, man. So thank you all for joining me. Hopefully he gets the Google interview on Tuesday and that he's able to pass it. Fingers crossed. So thank you all for watching. If you guys want to get coached yourself, you can book me for interview coaching at eChanTech.com after, I don't know if I'm going to stream on Tuesday. I think this will probably be the last stream for a while. Or maybe there'll be one more later on. And I will let you guys know if you are in the Discord, if you're on Twitter, follow me. And I usually announce things through Discord, so please check it out there. Until then, see y'all later. Thank y'all for joining me. Have a good night.